Today we are going to take a question in tacheometry. I have looked for a question paper for certificate in land survey, and I've seen a very good paper for July 2022 land survey certificate. So we are going to look at tacheometry, and tacheometric survey is a branch of survey in which horizontal and vertical distance are determined by taking angular observation with an instrument known as a tacheometer. So a tacheometer is an instrument just like a theodolite, fitted mostly with an analytic lens, and that is what we are going to tackle today in our question for today. So this is question number 7, land survey. So let's look at the question. The observations shown in the table 4 were taken with a theodolite fitted with an analytic lens to verticality of the staff. So the staff was held vertical. The theodolite had a multiplying constant of 100. If the height of the instrument was 1.45 meters, the reduced level of R, here the staff station R, is 2085.840 meters, and points R, K and S are collinear. Calculate the gradient of RS. So this whole question carries a total of 20 marks. I think this is a very good question in which we can tackle. So this question applies to both certificates in land survey, diploma in land survey, diploma in building module 2, diploma in civil module 2, diploma in architect module 2, and also the final paper of quantity survey done in module 3. So let's look at the table. So here we have instrument station K. From instrument station K, the staff station R and S are here. Then we have a vertical circle reading of 86 degrees, 30 minutes and 45 seconds. Then from K to S, we have 83 degrees, 45 minutes, 15 seconds. Then we have a stadia reading. So here we were only given 2 readings, and as per your information, in tacheometric survey we have different methods in which we can get our readings, but here in these questions we are going to deal with the common method that we always have. So that is the fixed hair method, and in the fixed hair method we use 3 crosshair to get our values. So in the fixed hair method, so here we must have 3 readings, but in our stadia readings here we have a mid and bottom. So we are supposed to have an upper value. So the difference between those 2 is going to give you the reading that should be on top. So that is what you are going to see when we will be calculating for S. And in this concept, as you know, so S stands for the staff intercept. So that is the reading between the bottom and the top crosshair in the staff readings. Yeah, so having looked at that question, let's go to the calculation. I had done the calculation here in order to make the lesson a little bit interesting and faster. So here we are given a vertical circle reading, and from this vertical circle reading we have to find the vertical angles. So the vertical angles are the angles we need in order to calculate what is given in the question, and the vertical angle is obtained from the vertical circle reading. So this vertical circle reading is a whole bearing, a whole circle bearing. So here in this question, we have been given the vertical circle reading. So this is the vertical circle reading, and we are supposed to get the vertical angle reading. So this vertical circle reading represents the whole circle bearing in the diagram. So let's go to the solution. Here in our solution, if I draw the instrument which is parallel to the line of axis of the same instrument, so when a compass is used, provided the compass is in line with the line of axis which is the same as that, and our difference will be, so the difference will be seen there, and when the difference is seen there, here the value that we have, so the whole circle bearing will be gotten. So we find the difference between the line of axis that we have been given and the line of axis which is parallel to the instrument. So all these points will have to converge in the first quadrant, and where our first quadrant ends is 90 degrees. So we come here, so 90 minus 86, 30, 45. So here our angle will be at an angle of elevation, so here will be plus 3 degrees 29, 15, and the below angle, so 90 minus this value that we have there, will have a negative 3, 45, 15. So the angle here will be at a depression angle. So having gotten that, we have found the vertical angles used in this calculation, and from there I come and draw my diagram which will have a simple representation, and from this diagram I can get the points that I need. So in the question we were supposed to find the gradient. So before we find the gradient, we first have to find the horizontal distance, we have to find the vertical distance, then we have to find the reduced levels of all these places. So we have been given the reduced level of R here. So when I represent this information in the table, so the angle of depression, so the value will be below the instrument, and the angle that at an elevation will be on top. So from the data that we had there, so from K to R we had a positive, so the instrument was at an inclined angle. Then from R to S we had a declination, so the angle will be below. So V is the distance between the vertical axis of the instrument to the mid point, so the middle reading, so the midpoint of the staff. Then from the mid staff to the bottom of the staff we have R or H in other books. Then the staff intercept will be the difference between the top and the bottom readings, and then we'll do the same to here. So V is the distance in the line of axis to the middle, then R is the distance from the mid to the bottom of the staff, and then the staff intercept is the difference between the top and the bottom of staff reading at R. So we go ahead and we calculate the horizontal distance 1 and the horizontal distance 2. So the horizontal distance 1 is the distance between S and K. We go to the calculation. So this instrument was fitted with an analytic lens. So having been fitted with an analytic lens, the equation where C is will be equal to 0, constant C will be 0. So when multiplied by 0, every value there, even the cos square that we had there in the formula, will be 0. So our answer will be simplified to T, which is the horizontal distance, is equals to Ks cos theta squared. K is the constant which is 100 in any analytic fitted instrument. So K is 100 times S. In the question that we had been given here, so S, so K to S, so the difference, so the mid, bottom, and we are supposed to have a top reading somewhere. So if we have a top reading somewhere, so the difference between these two is the value that we need to calculate in order for us to find the right answer. So the difference between these 2 points will give us the difference between the mid and the top. So we were supposed to have 3 columns, but here the examiner has decided to be a little bit cunning. So here they have eliminated the top stadia reading, and this is the fixed stadia cross here. So if it is fixed, that means the difference and the interval between those readings will be the same. So the difference between the mid, the difference between the mid here and the bottom will give us the difference in the two. So the difference between the mid and the two will be the same as the difference between the mid and the top. If we had a column here for the top, the difference is the same, because this is a fixed here stadia calculation. So the difference between these two will give me the difference between the mid and the top. So we go back to the question. So the difference between those two will be 0.795. So if that is the same difference, that means the difference between the top and the mid will be the same. So I multiply my answer by 2 in order for you to find the stadia intercept. So the difference between the top and the bottom crosshair will be there. So when multiply by 2, we get 1.59. Then we go back here. So this is cos squared theta. So in the calculator you input cos 329.15. Then your answer, you find the square of that answer. So how we finish that, that will be the value for D1. Then we move to D2, the distance between K and R. So K, constant K here is 100 times the stadia intercept between those two. Go back to the, so this difference between the mid and the bottom multiplied by 2 will give you the staff intercept here. So when you find, the value will be 1.08. so multiply, so this 0.454 multiplied by 2 will be 1.08 times 0.957. so that is the answer of the square of the cos. So D2 will be 107.54. We go back. So we need to find the distance between R and S, which will be used later in calculating the gradient. So here we have already calculated the distance between K and S, D1, and K and R, D2. So the values are there. I have already written them. So we go back to mathematical calculation. So this is a formula in trigonometry calculation. You can go back and refer. So mostly it is taught in form 3, form 4, somewhere there. So I want to find the distance between R and S, and we are told in the question that the points R, K and S, they are collinear, and when you go back to your dictionary, collinear means straight. So there's NB, collinear means straight. So these points are straight. So if they are straight, I find the difference in the angle between them, and it will give me the answer that I need. Here we have been given the so if these angles were straight, I don't need even to use the, so here we have not been given the horizontal circle reading. I go back here and I use the vertical circle reading provided to us because these points were straight. So if they were straight, I can use the vertical circle reading to find where those points were. So if those points were straight, the only difference in those points were the vertical circle reading, because the points, they are on a straight line. So if here we have K, it is straight to R, and the same, it is straight to S. So the only difference between these two will be provided in the vertical circle reading that we have here. So we use the vertical circle reading in order to find the angle that was different in those points. So when you go back and you draw the compass, having moved from the true north, you go in a clockwise direction. The difference was those two angles. So the difference between this angle and this angle will provide you the angle between those points. So when you subtract, so this is 93, 45, 15 subtracted by 86, 30, 45. Here we'll have 7, 14, 30. So that is the difference in the angle between those points. And if that is the difference between the angle between those points, that means I can use the trigonometrical calculation in order for us to find the value of RS. And from Mathematica, so the square root of the distance RS will be equal to the square root of KS plus the square root of KR here minus 2 times the distance KS times the distance KR times cos theta. So cos theta is the angle difference between those 2 points as observed here. So having done that, so here is the calculation, and if you have a normal calculator, you make sure you do this part separate, then the other part separate, then your answer you subtract. After subtracting, you find the square root, because here we have a square and we need to remain with an only value. So RS will be 53.47. So 53.47, that is the distance between RS. We move to the next point. So we need to calculate the reduced level of K. We go back to our diagram, and if we look here, if we want to find the reduced level of K, and we already have been given the reduced level of R in the equation, the reduced level of R there, we come and look at it. So the reduced level of R somewhere here. So in order for us to come and get the reduced level of K, so we add, so the reduced level of R, so that will be the reduced level of R plus the distance to the midpoint, that is R here, or H in other books. Then we subtract the vertical distance V in order for us to come to the line of axis or line of collimation of the instrument. So when you subtract, we move to the line of collimation of the instrument, and then we move below. So when you move below, so we subtract the height of instrument. If you subtract the height of instrument, we'll get the reduced level of K. So here we calculate the vertical distance V is equals to half KS sine to theta. So S we had already there. We find, so V will be 9.67. So we come here. So having done that, so the reduced level of that we had already been given there of R here plus R, that is the distance to the midpoint already given in there. So the distance to the midpoint here, we have already been given that distance. So the distance in the midpoint there, then minus V already calculated it, then minus the height of instrument that we had been given in the question. So the reduced level of K will be 2077.315. Then we go and find the reduced level of point S. Go back to our diagram. So if we have the reduced level of K and we want to find the reduced level of S, we move. So the reduced level of K plus the height of instrument, in order for us to go to the line of axis or line of collimation, then we subtract the distance V, vertical distance, then we subtract R, the distance between the mid and the bottom, and we'll have found the reduced level of S. We go back. So here we calculate V. V will be a half KS sine to theta. So all these values are in the table. S we had calculated it. So V will be 7.07. We go back. So we use the reduced level that we had calculated earlier there. So the reduced level of K will be 2077.315 plus the height of instrument, which is 1.45 provided in the question, plus V, which we had calculated here, then minus R, which is provided to us. So that is the mid. So R roll small h. So the reduced level of S will be 2082.55. Then our last section, we are supposed to find the gradient. So the gradient is the difference between the y-axis over the x-axis, and we find the gradient. So we already had been given R, the reduced level of R. I have represented it there in the graph. Then we have the reduced level of S that we have gotten now. So the difference between those two, divide by the difference between S and R, and we had calculated that here. So S and R is 53.47. so that is the difference between those two. So when you find the difference between those two, you will find your gradient, and you will have finished that equation. So the gradient of this point will be that simple. So that will be reduced level of R minus reduced level of S over 50, so 53.47, and you will have gotten your answer. Simple as that. So that is everything. That will be all. So stay tuned for more examples and the PDF that I've displayed there. So if you check in the comment, you will find the PDF, and you can use that and calculate